Imagine waking up to find the engines powering your nation's most advanced airplanes have not vanished, but are now locked away by a distant superpower. This is not science fiction. It is the current reality for China's rising aviation industry. The consequences could ripple far beyond the runways of Beijing and Shanghai, shaking the very foundations of global aerospace. For over 2 decades, China has poured hundreds of billions of dollars into building an aviation sector to rival Boeing and Airbus. The dream: break their near monopoly and put Chinese jets at the heart of both domestic and international skies. This ambition produced the COMAC C919 and its regional sibling, the C909, now symbols of China's push for technological self-reliance. The C919, China's answer to the Airbus A320 and Boeing 737, began commercial flights recently with carriers like Air China and China Eastern. Its regional counterpart, the C909, once called the ARJ-21, has established a strong presence in regional markets. Today, analysts estimate more than 170 C909s operate on dozens of routes in China and nearby countries. The newer C919 already has 18 aircraft in service, and this number could rise quickly if supply chain obstacles are overcome. China's future goals are bold. By the year 2040, the nation expects its aircraft fleet to near 10,000 planes, almost a quarter of the world market. That means around 1 in every 4 commercial planes could be Chinese-made, a leap from just a generation ago when China depended entirely on foreign suppliers. Yet beneath this ambition lies a vulnerability. Despite calls for self-reliance, Chinese airliners still depend heavily on Western technology, especially in engines and avionics. The C919 uses the LEAP-1 Charlie engine, made by CFM International, a partnership between General Electric of the United States and Safran of France. The C909 relies on the CF34-10 Alpha engine from General Electric. Other key systems come from American firms like Honeywell and Collins Aerospace, providing avionics, flight controls, power systems, and pilot interfaces. Recently, the United States suspended export licenses for these vital engines and components. Honeywell, Collins, and General Electric, once crucial to China's aviation ambitions, have seen their supply chains thrown into disarray. The result? Production of new C919s has slowed dramatically, threatening China's plan to ramp up output to 50 aircraft annually. The stakes are massive. Boeing projects China will need more than 8,700 new commercial aircraft by 2040. A market worth nearly $1.5 trillion US. These are more than numbers. They represent jobs for hundreds of thousands, the fortunes of airlines, and the travel plans of billions across Asia and beyond. For China, this is more than an economic setback. It is an existential challenge. Beijing has responded by accelerating the push for homegrown engines and critical parts. The Aero Engine Corporation of China, or AECC, is leading this charge. Its flagship CJ1000 Alpha engine is meant to replace the LEAP-1 Charlie on the C919, but the journey has not been smooth. Initially slated for service by 2020, the CJ1000 Alpha has faced nearly a decade of delays, now aiming for commercial readiness by 2030 at best. Shi Jianzhong from the Shanghai Society of Aeronautics warns, "There's no shortcut to true aerospace independence. Success depends on sustained investment in advanced materials and manufacturing." Jet engines are among the most complex machines ever built, demanding mastery of exotic alloys, precision, and quality control. Even small flaws can have catastrophic consequences. Yet, technical and regulatory barriers remain steep. Certification in aerospace involves years of data collection, safety testing, and international validation. As one analyst at ePlane AI puts it, bans will make China catch up faster, but matching Western engines in certification and reliability is a monumental challenge. Building a working engine is only the start. Proving it safe for tens of thousands of flight hours is another matter. The world is watching. Will China's urgency and massive investments bridge the gap before supply lines run dry? Or will US-led restrictions create a long-term bottleneck, holding back China's aviation dreams for years, perhaps decades? The answer will shape not only China's fate, but also global technology, trade, and diplomacy. Let's look at the bigger picture. The US export ban is already sending shockwaves through global aviation. Some experts warn that we are entering a new era, a tech Cold War, where nations compete not just for markets, but for technological dominance. Unlike the US-Soviet rivalry of the 20th century, Today's contest is complicated by deeply integrated supply chains. If China succeeds in building domestic engines, power in the aviation industry could shift dramatically. Xi Jinping notes, a breakthrough with the CJ1000 engine would show the world China's supply chain resilience. But this will take not only money, but years, maybe decades of research, a willingness to accept setbacks, and a commitment to innovation. The stakes could not be higher. If China's aircraft fleet nears 10,000 by 2040, it would rewrite the rules of global commerce, labor, and geopolitics. Airlines worldwide, from Southeast Asia to Africa, could soon choose between Western and Chinese aircraft for the first time. But there are risks. Fred Teng warns, export bans may offer temporary leverage, but over time, they can weaken the very industries they aim to protect. U.S. companies like Boeing and General Electric could lose lucrative deals, giving European or Asian rivals an opening. A fractured global supply chain could also mean higher costs and less efficiency, making air travel more expensive for everyone. Other players are watching closely. Airbus in Europe and newcomers from Japan, South Korea, and India see opportunities to fill the gap. But these come with risks, as companies could be caught in regulatory crossfire or face retaliation. Several futures are possible. In the best case, China's investment pays off, leading to breakthroughs and near self-sufficiency by 2035, sparking new competition and innovation. Or, the confrontation could escalate, with tariffs and bans hurting both sides, slowing the industry, and raising prices for travelers. There's also the chance that other nations step in to supply China, weakening the U.S. hold on global aviation, but risking friction with Washington. The most likely outcome? A gradual decoupling, with China gaining more independence, the U.S. maintaining some access, and the industry becoming more fragmented, but also more competitive. What does this mean for you? It shows just how fragile and interconnected our supply chains are. We assume that complex products like airplanes will always be available, but political decisions in Washington or Beijing can disrupt entire industries, delay flights, and raise costs, even for your next vacation. For investors and business leaders, the lesson is clear. In an unpredictable world, adaptability and diversification are essential. Companies relying on global supply chains must monitor geopolitics and prepare to pivot quickly. Those who invest in resilience will be best positioned to thrive. For tech professionals, engineers, and students, this drama is a wake-up call. The future of aviation and advanced manufacturing depends on skills in artificial intelligence, advanced materials, automation, and cross-disciplinary teamwork. As Mei Qing, General Manager of AECC Commercial Aircraft Engine, points out, general artificial intelligence is not enough. We need specialized frameworks, powerful computing, and a new generation of talent. For travelers, the rise of new players could mean more options and lower prices in the long run, but also more unpredictability in the short term. Will your next flight be on a Boeing, Airbus, or COMAC? The answer may depend as much on global politics as on engineering. The bigger lesson, national ambition, technological mastery, and international cooperation are forever linked. The future depends not just on one engine program, but on the ability of nations and industries to collaborate, compete, and adapt. Can China achieve true technological self-sufficiency before its aviation dreams are grounded? The answer is complex. On one hand, China is making rapid progress. Its CJ1000 Alpha engine is being tested, backed by record investment and a national focus on innovation. On the other hand, major challenges remain: technical hurdles, certification barriers, and ongoing tensions with Western suppliers. Liu Daxiang from Beihang University notes, China must move beyond copying Western designs. Achieving true self-sufficiency by 2035 demands original research and risk-taking. The most probable future, a world where China and the U.S. gradually decouple in aviation technology, each keeping partial market access under stricter controls. The industry will become more fragmented, but also more dynamic, driven by rivalry and relentless innovation. And here's an intriguing fact. Much of the software powering both American and Chinese jet engines traces back to joint projects from the early 2010s. It's a subtle reminder that, beneath rivalry, seeds of collaboration still exist. If you found this story revealing, please like, subscribe, and turn on notifications. Will China soar on its own engines, or will global tensions ground its ambitions? Share your thoughts below.